After writing the base codes for those three classes, we can actually go back again to the design phase. So in the design phase now, we can design more classes to extend our software system. So to do that, let's say we have designed or we have think of two other entities that are needed to further extend our existing objects. So these two classes, we can identify one as name and the other as address, which will be used for the students class and the faculties class. So the name, let's design, it will have three particular fields: the first name, middle name and last name. And then we can have two constructors. So how many constructors and what will be those constructors, what will be the input parameters of those constructors? These are design choices made by the developer. So in this name class is designed by me, and my choice is not to have any no argument constructor, because I don't want empty name for any student or any faculty member. Rather, I want to make sure that any person will have two parts of the name at least. So I have two constructors. One is called name, using just two inputs, first name and last name. Another one, the same name, but it has three inputs, first name, middle name and last name. And finally, I have a method get name that will actually concatenate all these three fields and give us a complete string. So you may ask why I don't take the name as a full string, why I'm taking separate strings for first name, last name and middle name. So this has effects when we want to sort students based on last name, or uh, we want to search a student where we have only one part of the name. It's better to have the name separated in this way. Similarly, for the next class, address, the address class, we see that here also I'm not taking address as a complete string. Rather, I'm designing address as an abstract data type, where I have all these data fields: house number as string, road number as integer, area name as string, the city and postcode. All these are private data fields. So you can again ask why I'm taking address in such a way. Again, in my software system, if I have address in this way, I can easily search how many students or how many faculty members live in a particular city or in a particular area, and by using that information I can take some important decision maybe. But if I had taken address as a complete string, I could not separate automatically all this city information or postcode information and so on. So for my address, again, my design choice is any address will have all this information as a mandatory field. Then I have a get address method that will give me back the address object with all these data fields. Then a get full address method that will concatenate all these as a string and give me back the string as an output. And then a set address method where I'm taking a new address and it returns nothing. So this is because once I have created a person and that person's address can change, so there's a write option or modify option for this set address, which we did not have for the name, because in my design choice, my design choice was once a person is created, his or her name cannot be changed, because that's not very usual case to change a person's name. With these two classes now added in our design, we should now define the relationship between these classes and the student or faculty classes. So what are these two relationships? a student or faculty has a name, a student or faculty has an address. An address can be shared by several students or faculty. For example, in my building, there is a student from my university. So for him and for me, we share the same address. So we should redraw the UML diagram with these extended classes. So here I'm just showing one part of the UML diagram. Okay, so we can see that name class is now connected or related to student class. Similarly, address class is related to student class. And also in the relationship, we have seen that there is no relationship between name and address, so they are not connected. Next, we will quantify the relationship. Since before quantifying, we can see that the relationship is particular, and this type of relationship is called ownership. So one class, the student or faculty class, is owner of the second class because student or faculty has name. So if we were to giving the relationship a name, the name would be has. Similarly, student has address. Student has name. So this, since this has is a very common type of relationship, so instead of writing the name has, we depict this using this diamond symbol. So the diamond symbol is given with the owner class, student, and with the owned class, there is nothing. So if we have this diamond symbol, we don't need to write the name of the relationship and we don't need to show the arrow. Then we can actually quantify the relationship. So a student has one name. Any person has one name. Similarly, a student has one address. So a person has one address. So in the other way, a name, so we can actually consider that a name is unique for this case, for this example case. So a name is owned by one student only. But we have seen that an address can be shared by several people. So address is owned by multiple students. So when the relationship or the ownership is unique, for example, name is owned by only one student, that unique ownership is depicted by this filled up diamond. And we will see shortly what this unique ownership and simple ownership, what is the difference between these two. So we can see that the new type of relationship is called ownership. So any sort of relationship is known as association, but now we will see aggregation, another type of relationship, which is simply a special form of association that represents an ownership between two objects. So it means it models has a relationship. For example, we have just seen a student has a name or a student has an address. So the owner object is called aggregating object. So here the student is aggregating object and the subject or owned object is called aggregated object. So the name and address class is our aggregated object here. So when we say, okay, this is aggregation type, this is an ownership relationship, this is simply in theory or in designing phase. In actual code, the aggregation relationship is usually represented as a data field in the aggregating class. So when we say that a student has a name, it simply means a student has a data field which is a name type object. Similarly, when we say a student has an address, it simply means inside the student class, it has a data field type address. So ownership is implemented by using another class as a data field of some class. So this is called aggregation. After considering the ownership relation as aggregation, we have just also seen that an object can be owned by several other aggregating objects. For example, a same address can be owned by more than one student or faculty. But if an object is exclusively owned by an aggregating object, that relationship between the object and its aggregating object is referred to as a composition. For example, a name is unique for each student or faculty. So aggregation and composition, usually they are not differentiated. So in our next communications, we will simply call both of them as composition. So in total, a composition will depict an ownership relationship for our discussion. So this is all about class relationships, where we can see that these particular relationships for just has no other coding style, or there's no separate keywords to implement. Rather, it simply means when we use one class as data field of another class, or we can have some methods which takes input type of some other class. So by using the other type of classes as data fields and formal parameters for our methods, we actually implement these type of relationships. So in the next class, we will see the last type of relationship called inheritance.